Good morning. My name is Menno Mekes. I work at Arons Gelauff Architects, and I modeled Pontsteiger. This is Jeffrey Truijens. He was one of the BIM directors for Pontsteiger and works at the Dura Vermeer, the construction company who joined forces with building company Designclash to develop and build Pontsteiger. Now, before Jeffrey and I start talking about how this building was engineered, let me give you a quick introduction to the building itself. In 2006, we won the competition for Pontsteiger, a building to mark the new old part of Amsterdam, Houthavens. These former timber docks are being transformed into a housing area. Me and my colleagues worked very hard on filing the 2D building permit and finished just in time before the financial crisis hit. It got cancelled. In the years that followed, many attempts to revive the plan had failed, until 2014, where Dura Vermeer and Designclash bought the land, the water, the plan, and luckily they bought us as well. Construction started in 2015, and now we have a proud award-winning landmark, Pontsteiger. But why does this building look like a chair? We were allowed to build a tower of 150 meters high. But should we? Because all the local towers in Amsterdam are about 90 meters high. It's a housing project, so we need to take into account where people would like to live. It's no surprise to you that most people would like to live in a penthouse or at ground floor. So an hourglass shape is therefore the optimal solution. Of course, we tried many other shapes. Now let me recap months of hard design work in a few simple steps. A tower. A high tower would be a landmark, definitely. You would have a great view over Amsterdam, and you can even see the sea. But what about the public space? Tower entrances are always windy, the view is for the happy few, and the surrounding area, Houthavens, will be low-rise. A block then. Everybody would be living at the ground floor, near the water. The building would be in scale with the surrounding Houthavens, but there's an interior space. We would say, make it public, but the residents would like to keep it private. Oh yeah, we also got a footprint in the design brief, and a building like this would never fit. A block tower then. Lots of people would be living with a great view. It's a high-rise, so it can become a landmark, and lots of people would be living on ground floor near the water. And if we lift the building 2 stories, we also solve the public space. Now, Pontsteiger means ferry dock. The old ferry dock was demolished to make room for 2 layers of parking. Public spaces, entrances, and the new ferry dock. On top of that, the block tower. Low-rise and towers contain 300 rental apartments. On top of that, the part that we call the bridge, which contains 66 market apartments. Expensive apartments with a beautiful view. Okay, Jeffrey, let's build this landmark.
Thank you, Menno. Very nice to see that an architect with such a vision can realize such a beautiful project. But how do you organize such a project? For us, it all started with agreements, because with agreements you can come to a good collaboration, and with a good collaboration you can make such a landmark. So, how do we start? Get a room. So, if you get in a room with people, you can discuss the different ambitions that all the parties have. And also you can stretch each other to do a little bit more than they're used to. So, that's what we did. We defined our ambition, and then we started. Not by reinventing everything yourself. Lex van Zijn, also here in between us. Together we sat down and we said, okay, how we're going to organize it. So we had a simple statement. Use and combine available knowledge and standards rather than reinvent it yourself. And that was our motto during the whole project and even now. So, in the Netherlands, we have the beer with also the BIM locket. And they described a vision about different stages of BIM. You could start by sharing documents, but that's not BIM. You can start at your own company using BIM models, but that's not BIM. No, we said our ambition is a level 2. So we want to share and organize BIM models throughout the whole supply chain. And we decided with the whole team that this would be the ambition. What is our way of work? So we also not reinvent it ourselves, but we borrowed it from Gieling in this point, and we used it a Hamburger model. I don't know if you know it, but it's a way to look at a project and to organize your project concerning the information management. So it has really a demand and supply side, and it's the key to have focus on the project itself. So everybody doesn't have to look at his own part, but it has to look at the total. And then you can see you have a demand side with designers, the architect, the structural engineer, the MEP engineer, and afterwards you get together with the suppliers, with the people who install the MEP, and you get all the knowledge on the table and get the best product for the client. So, two parties who not only built this project but also developed the project. So the most beautiful thing I think what here happened is that we got one vision on how to BIM. No company started standards, but just from scratch and with all open standards in mind. So typically naming the why, the how and the what. So we could convince everybody who wants to join this project knowing what is expected of them. So a simple plan. But a plan is not only a plan if you don't explain it. So we all made supporting documents to explain to people how to use open standards, because it was in 2014, 2015 in the Netherlands not common to use open standards and to agree on this kind of things. We made mousepads for the BIM modelers and the BIM engineers to make it easy for them to follow our agreements, because you can say, hey, here's your contract, do like the contract asks you to do, but you can motivate them, you can help them to really accomplish that. So that was really the story about agreements, and then you have to go into the project and help each other. Help each other to export the right IFCs, help them to put in the right information and to find the information by use of classifications, and make sure that if someone doesn't get it, you explain them what's handy about it. So we can do all kind of stuff to show to other people how this works. If you want to hear more about how we did it with agreements and how it evolved to a Dutch standard way of work, just sit down and come at noon, because Lex and Menno will gladly take you into the BIM basic idea.
Thank you. The biggest challenge in any BIM process is working together. As you all well know, a BIM is not one file made by one company. It's a lot of files made by a lot of companies. So in order to clash, we first need to build our models according to all the agreements that Jeffrey just explained. I mean, clashing two perfect models will still result in too many issues if there is no communication. We need to get together. Now, this was already a challenge in the design phase, where there were only three companies that were working together. Now, we all use the same software, Revit, so we could link each other's models into our own to create a fast workflow. 5 years ago, we were still getting used to the Revit server and all the demands regarding openBIM. So every 2 weeks, we would export our models to IFC, which was then checked by the contractor and discussed in meetings. Now, we not only need to get together, we need to start working together. And now, we need to get even more technical with more people. That's why we decided to dedicate every Thursday on the project. Now, I would start in the morning modeling. At 9, there would be a BIM meeting where we would discuss all the issues and clashes. And yes, there's a big difference between an issue and a clash. For me, as a modeler, it was very convenient to stay all day Usually after a BIM meeting, lots of people would go back to the office, but I would stay, work on the issues at hand. And all day I would attend all the technical meetings, so details were drawn on flipovers and smart boards. So direct input for the model was being generated. And we work with people from all over the country, so elements and their engineers had to come from all corners. So spending time efficient was key. And by the time they went home, they would check up on me and could already see some of the elements in 3D we had already designed in the morning. And now let's build together. The openBIM approach is applicable to anything. No islands, no secrets, no worries. We share everything we do and make. And yes, that can be very scary, especially for smaller companies who are afraid of being taken advantage of. And concurrent engineering is a place outside most people's comfort zone. But it makes building a lot more fun.
So, when you get together, you make good models. Then the next step is to coordinate all those information in those models. So how did we do that? Starting point, the Hamburger model. It allows us to get focus on the several points of model coordination, and I will take you to it in a briefly way in our 4 steps. So the first step, first of all, check if the model is okay in itself. Did it comply to all the agreements that we make? So check the different parts of the agreements, and if it's not okay, first fix that, because if you want to coordinate, this is the basic. Then step 2, you want to get your demand models all online, because it's the communication towards the suppliers which they get on working. So we did 2 things. We did the visual control, so looking at the models and detecting any errors. But also by clash control, setting rule sets between the different disciplines and to make a control about it. Then step 3, look if the supplier delivered what in the demand model is modeled. So you can check if it's between the agreements. And then you can filter the model and you can check if it's okay. So you can make a demand model and you can overlay it with the supply model and you can check if it's okay. You can look at the different parts of it, and by clash control you can automatically detect if it's okay. So this is a supply model and it detects any emirations. So here you see all the things you maybe have to check. Then step 4, check the supply models with each other, because this is a crucial step in towards assemble the building at its place. So the detail level is really getting up, and the importance to check this throughout the whole project is really important to have no problems assembling the building. So here you see a beautiful example of that. Then, how do you organize all these model coordinations? You have different roles. So every team got its own BIM coordinator, and we had, because of the scale, also 2 BIM directors. Mark and Mike, they were really great. Lex and I were thinking a lot about which agreements do you have to do, and these were the pit bulls who really made it happen and get all the parties aligned. So really great job what they did. And what they really did is activate the whole team using trusting models. And that's really an achievement, because at that time, not all the companies were used to work like this. So you see all kind of pictures about working together with the models in mind, helping each other, and I think a really beautiful example.
BIM director, a new profession in the building industry. With BIM, remarks should not be made on 2D drawings. This is a thing of the past, since annotating a 3D model into old-fashioned 2D drawings takes forever. Now, the best thing about openBIM is the export to IFC. And because every building phase was a couple of months too short, we may have created a few issues we couldn't resolve before creating new ones. About 6,000 of them, of which 800 are mine. 5 years ago, we were still getting used to openBIM. Didn't know all the IFC parameters just yet. So for example, the Dutch NLSB classification code, it has been around forever, but as architects, we don't really use it that much. And contractors, they especially use it for filtering and sorting. So all these issues were then stored in reports that we would discuss every other week. Now, clashes, I really don't have to tell you this because everybody knows what a clash is, obviously. Clashes are, the contractor did this in Solibri, see if geometry intersects with other geometry. Or maybe check if a window can still be opened and doesn't hit a column. Now, as a team, we got to test the issue management platform BIMCollab. This is a website, a portal where all issues are stored and are accessible for all the team members. Issues and BCF files can be uploaded directly from the Communication tab in Solibri. Now, when creating an issue, you can decide what kind of message you want to relay. Is it an issue, a fault, a clash, request, inquiry, remark? We just stuck with issues and clashes. Keep it simple. Now, I would sometimes create an issue if I would like someone else to change something in the model. Usually this is already discussed over the phone or in a meeting, but by creating an issue, the whole team knows that we discussed this. So in this example, I show Harry, the structural engineer, what wall opening he should remove and which one he can leave in. So I create the issue, Harry then changes his model and resolves the issue. Now this is very important that the resolved issues are still open. They are then checked by the contractor, and if agreed upon, the issues can be closed. If not, the issue can be reopened. Now, looking at slides in a meeting is nice, but I'm a modeler, so I have to fix these issues and clashes. So with BIMCollab came the Revit BCF Connector. Now, there are other connectors around, but this one has the advantage of a direct link to BIMCollab. So in Pontsteiger, we've learned two important issue management lessons. First one is always be very careful when creating issues. Always use only one or two elements that are related to the issue and not all elements visible in view, like you see here. Use the area correct, so the modeler can filter by model. If I work in a facade model, and there are already 3 facade models in Pontsteiger, I don't want to see or accidentally double-click an issue that is related to something in the basement. Now, you can also use the milestones to push issues forward in time to the next building phase, because most of the obvious clashes I showed you earlier on are less important in the design phase. Of course, you need to keep them in mind, but work on the bigger picture first. Being able to open a window or change its glass panels is far more important when designing a building. Now, Pontsteiger followed the 80-20 rule in everything. 80% of this building is being prefabricated. At 60 meters high, from a boat, 4 steel frames the size of a bridge were placed on top of prefabricated concrete walls. Now, they all fit. No cutting, no welding, no braking, just hoisting and fixing. Now, if you think 6,000 issues is a lot, it's necessary. To build like this precise, we have to simulate everything in the BIM beforehand. So Pontsteiger is big. It's really big. All the prefabricated elements are big, heavy, and numerous. I even had to cut a few of these in half because the crane couldn't lift them. But that is the mass of the building. At ground level, we've created 4 beautiful curved pavilions, wooden curtain walls with straight glass panels. And here we find a hidden treasure of prefabrication, concrete window sills, 400 of them and 280 unique ones. So you see that prefabrication is not just about the sheer number of repetition. Okay, Jeffrey, Tell me how you got all this onto site.
So it's one thing to have an ambition to do it like this and with all the prefabrication. And in the Netherlands, it's really a trend to do more and more prefabrication. But it has also consequences for the way you organize your building. So we had to support the site in the right way. So what did we do at the start of the project? We certainly made it sure that the construction site is totally in BIM. So not only to make it visual about what's coming where, but also to think about logistics, communication with the municipality, and the certain things you have to encounter. So what we did is think about the crane movements and the crane weights, what's possible. But also we think about how will it get there? How will the crane stand on its own? And maybe it had consequences for the things we have to build. So temporary facilities are also important to take into account when you think of BIM. It's not only about the end situation. So what did we do more? Because all of the prefabrication, we have elements, but that elements had to stay at the right position. So all the props and the anchors that were needed were also taken into a BIM model. So we made sure that there was no drilling necessary on the site. And we had really a lot of anchors and props, but they were all coordinated and nothing had to be drilled on site. So that's really a time effort, but it has a beautiful result. Then we had another thing, because we had such a bridge construction, how do you do the ceiling from beneath? That's really a challenge for the whole construction team. So what they thought about was making a hanging platform. But making a hanging platform, how do you do that? Designing it first in BIM. So you can think about the consequences, you can make sure that it's possible, and then also, really important for us as general contractors, you can work safe. Because if we can't work safe, we don't work at all. So this is a way we get a beautiful result, but in a safe way. I think we have showed in the last presentation and in the way we did BIM at this project, I believe this is BIM at its best. Not only because we made a landmark with it, but also because we had beautiful details in the building. Some you will see, some no one will see at all. But this is really beautiful, in my opinion. And we had a beautiful team. And I believe I've made more friends on this project than any other project at all. And the beautiful thing is that they're all proud of being a part of this project. And we are even prouder that we won the award with this project. Thank you very much.